example 1 for U substitution. U substitution is a method of solving integrals that we haven't seen yet. All the integrals that we've been given have been simple enough integrals where we've been able to solve just using the antiderivative rule, which is add 1 to the exponent, divide by the new exponent, plus c, or the basic trig derivatives. We haven't seen anything that's been a composite function. So what a composite function is it kind of shows it up here. It's a function within a function. So if you have something like that, like cosine is a function and 5x is within it. So it makes it a composite function, or what we would need if we did the derivative, we'd need a chain rule. So if you have a situation like that, you can't just do the antiderivative just the way it is. What you'll have to do is use U substitution, and what that does is it takes out the complicated part of the problem, and then we'll do the antiderivative, and then it puts it back in. So U substitution, what we're going to do is take the complicated part, which in this one is the 5x. If the 5x wasn't there and that was just x, we would be fine. So what we're going to do is take the 5x and use that as our U substitution. So instead of 5x, I'm going to sub out the 5x and put in a U. What I'm doing here is I just divided my paper into scratch work part and then antiderivative part. So I like to keep things clear and organized with a line. All right, so the thing is, that's good to take out the 5x and to put in the u. So now it's 5 cosine of u. Much simpler having just a u instead of a 5x. But I can't write the dx because then I'll have a dx and a u, and those need to match. The dx tells you to take the antiderivative in terms of x, but now we have a u. So I'm going to go over here and work on this. So I'm going to do the derivative of both sides here. The derivative of u is du dx. The derivative of 5x is 5. So I just did the derivative of each side. U was du dx, 5x is 5. Now I'm going to solve for dx so that I know what dx equals so that I can substitute it out. So I'm going to multiply by dx on both sides. So du equals 5 over dx, and then I'll divide by 5. So dx equals du over 5. So now I subbed out 5x with the u, and now I'm going to sub out dx and put in du over 5, because that's what it equals. So the first step was to substitute, and I substituted out the 5x and I substituted out the dx. Got it. The second step is going to be, I just need a minute, is going to be to simplify. And here I ended up with a 5 on top and a 5 on the bottom, so those can cancel out. So I ended up with cosine of u du. The next step is going to be, now that I have antiderivative of cosine of u du, I can just do the antiderivative using the skills that I learned earlier in the chapter. What's the antiderivative of cosine of u? Sine of u plus c. So I basically had a pretty simple antiderivative because of the substituting that I did. So I could do cosine of u, make it sine u plus c, almost done. The last step is going to be to unsubstitute, and that means I don't want to have u in my answer. I want to have it be in terms of x. So I'll go back to what u is. It was 5x, and put 5x back in. Sine of 5x plus c. And that will be your final answer.